Hopefully everyone has a good starting fiscal years. I just watched an episode from Clear Value Tax, and he talks about his strategy of selling and buying silver or gold. So this video is not about any investment suggestions, but when I read this diagram, I will think about if I can create the same thing using Wolfram language. So there are fairly good tabular and time series feature in the language. So let me show you the code that I actually run to create this one, and also show you some functions like a histogram to collect the number of increase and down in this time series using period to period ratios. Yep. Okay, without further ado, let's start. So this is my notebook, and this is all the code that you need. Okay, it's 10 degree, slightly better than this morning. It's like 2 digits, so yeah, just keep on. So to just create part of the diagram, I start from 2010, so I did not use all the data back to from 1996. So what you can do is something like very similar that you can do with Wolfram Alpha. So this part shows you how to extract data. But first, I want to just grab all the dates from the beginning. That's 2010 January 1st to yesterday. So now is fairly now. It's January 25th, Sunday, and I just want to grab all the dates to yesterday. So the number of dates you can check is around slightly less than 6,000. So these are from the dates from January 1st, it's a Friday in 2010, to yesterday, it's January 24th, Saturday 2026. And the number of days exactly is 5868. So 5,868. But usually for all kind of like finance data, you can just extract these data that are business day only. So what I do is select all the days, and the criterion is whether it is a business day or not. And then take a look at the length of the date range is 4,024, slightly more than 4,000, but much less than these days. And then the next step is I just want to extract the value of gold, the price value of the gold on each day. This is a function and the map on the data range. So each date on in the data. So I can show you what's in the date. The DR is the data range. It's a random choice. DR. So it's something like the date object. You can convert it into data string for better storage. And if you want to customize the data format, you can just hover your mouse here and consult the documentation page to set up what kind of format you want for the data stream. Okay, so the next step is to include the dates. I have already downloaded all the data, so it'll take some time for you to download it, but it's not too long. But it really depends on number of values. You usually should finish that around a minute to extract all the data from that range. Of course, because this is not like specialized database for finance, so it does communicate to Wolfram Alpha and do some general request. It won't be as fast as SQL call, but this is very generic. You can extract a lot of data information about these entities. So you can just click this book sign, and it brings you to the documentation page for the entities, and you will have lots of different informations about that. Is entity class, and this usually you only need to extract its properties with one directly using this field, but for this one, typically with date dependent values, you need to specify option. It's called a date to the date object, and it gives you the price for that. So if you just give it like date object this year number, it will extract all the information from for 1 year. Here what I do is just kind of more tedious way is to specify the date range with each date points, and because I only wanted business day, so I just put all the valid data range for business days here. So it will actually do more queries than the one you see in the example. So it slightly take more time to do that. So to prevent that you run this code accidentally, there is a function called once. You can wrap it around this function to it only will run once. So every time you do evaluation the whole notebook, this part won't be triggered automatically. Okay, once we have the information for the gold, it should look like this. Let's give it a short. Okay, so this shows you all the price on each day. Okay. For some data you can have like more detailed like minute or hourly based price data point, but that's really not necessary in my case. So here I just convert into time series. Of course, if in the example you can see that if you just query this year number, you automatically have a time series. But if you do that just like what I do here, you can use the thing to convert the gold and the silver price into time series. Hit Shift Enter and Shift Enter here. So these are fairly efficient to compute, and then you can click the plus sign. It actually shows you it's a strong typed data object. So it has type quantity for the second argument, and everything in the first is just a data object, and this quantity object has a unit as a kind of a very useful unit in this realm. It's always dollars over the ounces, and this is a very typical ounce. It's called troy ounces, very different from the ounce that we use for food or liquors. Okay, and next step is you can create a tabular. If you just want using one time series, you can just use tabular right outside the time series. But if you want to create a larger one, for example, mine is with 4 columns. One is the data range, all the timestamps, and the price of the gold, price of silver, and GSR. That's the one of the measure the YouTuber used in the video is gold to silver ratio, and he mentioned that his trading strategy is based on this value instead of the actual price of silver, because that would be really complicated, because you have to adjust the US dollar inflation and the price for these two precious metals at the same time. But using the ratio, I think it's quite straightforward because it simply becomes a dimensionless object for you to compute. So we can just stick with the video and use just the GSR. In Wolfram language, this is actually quite good syntax sugar. So you can just show that it's so let's see. It's gold is a list, right? So it's a really large list of the price, and the silver is another list. They do have the same shape, and they have the same units for each number. So in this case, you can just use list over list. The language interpreter would automatically arrange or align these two lists for you. So you immediately have such a list of numbers. And while if you just have a list of numbers, it's quite hard to tell, what's the actual values is just by eyeballing. The tabular function is really useful. You can just hover a mouse on the function name, and it gives you the documentation page for this tabular function that has lots of features, and typically it's very suitable for these type of financial data. So let's run that, and immediately we have a very nice table for these prices versus the date, and we have price and their ratios all together. Okay, and the next step is we can simply, just you can just simply using data list plot around it. It'll give you 3 lines, but the issue with that is you see the price between the US dollar for gold is much larger than that for silver. So you will see like one line depicts the trend of gold very well, but this line is simply flat. So it's just too small comparing to the value of gold. So the good way to just split them. Okay. So for example, I have a time series for TSG and the TSS. That's a time series for the gold and for the silver. So you can create another time series. It's GSR, TS, GSR. Just put a TS to indicate these variables or numbers that's stored is of a time series object. Okay, so immediately you will have this graph, and this is the same thing as the graph we have in the original video. Okay, so we have the data. So this from 2010 to current, and now we can just treat it as all the regular and play with some dates like visualization tools based on the data we have. So in this case, we want to see what's the distribution of the data just by their frequency in a certain given range. So this is usually given by a histogram. It shows the whether these data are how they are distributed in space, just based on their value instead of the time sequence. So this one is histogram. So if you open the documentation, you can see there's a number of data points, and I have a B-spec. So here we see there are 2 ways to do that. One is specify the number of bins, and the syntax I use is a number inside curly brackets. So this means each bin has a width 1. So this depicts so most of them probably is between say 65 to let's see, this is probably around This is 90. This is maybe 96 or 94. So this is sort of a dominant range that probably most of the values of GSR occurs. And probably that's why the YouTuber says most time he looking for the GSR between 60 to 80. Okay, so that's the really like makes sense if you can make it to like 60 to 90. So you definitely include most of the occurrences. And the other thing is we can play with it is called a period to period ratio. So it is like, say you compare the price, what's the percentage change between February and March, and April to March, and May to April. Another way is to comparing that, like say the April of each year. So there are different ways to see how the data change on a time series scale. So in this case, I just do sort of rolling ratios. So day 1, day 2, day 3, and also always check the ratio between the price on the next day to its previous day. So this is easily done by this syntax. So what it does is rest is sort of get rid of the first item in the list, and this one is get rid of the last element of the list. So in this case, you sort of like shift the two same list like forward and backward, and once you do the ratio, it automatically does the sort of the period to period ratio for you. And for example, if you starting do that from the day 1, you actually get rid of the day 1, because for the ratio, the first point is day 2, the value of day 2 over day 1, and then day 3 over day 2, and so on. So the first date is dropped. So we only keep all days from second to the last. So this one gives you a new time series to include all the values. Of course, you can just plug this thing back into that, but since time series is usually some more useful, it actually gives you API to sort of reflect or just retrieve the value or information from the object itself. So you can just click that and click F1 or F1. So you can see these are the valid properties that's available for to extract values from time series. So this is the values property for this time series. So what I can do is just plot all the these rolling ratios based on their frequencies. So this is the chart of frequency. So it looks kind of symmetry about 1. So if everything is 1, the price really does not change. Okay, so there's like sort of slightly more occurrence for it to grow, but we also have some numbers for it to drop. So it's kind of like in the middle. But you should use another feature for that is you can add a scaling functions for the histogram. Say you have the edge spec. So edge spec here is these things. So you can specify whether it's PDF or CDF. So let's take a look at the CDF, the cumulative distribution. So it looks like the half point, most of the value probably is, let's take a look at the 50%. So it's kind of like symmetric about middle 1. So, but maybe it's slightly more toward dropping the GSRs. So you can use other functions to extract the exact means or variation based on these empirical distribution for the data. Okay. The other way to handle that is probably we have a lot of noise in daily ratio to period to period ratio or day to day ratios. So maybe we want to see if the data has some pattern, sort of like weekly. But if we want to make sure we mention like weekly pattern. So is it like Monday comparing to Monday, or Tuesday comparing to Tuesday, or Friday comparing to Fridays? So this can be done using the time series resamples. So it will automatically create a new time series based on the sort of specification you give for the time series. So this one is I specify I'm only interested in days data point at Monday. So this immediately gives you the gold price of a Monday, and I can do the same thing for the like GSR, or not necessarily GSR, just the gold price from Monday to Mondays. So what I do is kind of similar, but you have to do sort of the same thing, but only on Mondays. So what I do is first get this data for the TSG Monday. So this is all the dates, and it's all the values, and really does the same thing as the previous example. And immediately I have a new data points, time series. So in this case, I can just take a look at these, and because this shows you what's the change of the price from this Monday to the next one. So I can just do the same thing for that one, and take a look at distribution. And it seems this time is definitely more sort of the more like data points, more than one. So sort of on weekly base scale, I can see clearer pattern that this trend tends to be more on this side, right, for most time. But you also want to notice that, say you have you drop 50%. To get the number back, you have to get 100. You have to get 200%, right? So in this case, if I do have something like far away from 1 on the left hand side, I actually need a way more point on the right hand side. So that's why it's, even though it looks like we have more like increase on the right hand side, but overall trend seems to be dropping sometimes. But well, this is also just very empirical, right? You can there's a lot of noise and things you can you have to taking care of the data. That's just my sort of very, very empirical and eyeballing the data points. But overall, this notebook and the project is just for you to use the tool and visualize it. And it's really not a suggestion or strategies for you to invest. That's my disclaimer. Okay, so hopefully you enjoy this tutorial and see how these codes are used in action. And see you next time. Bye-bye.